Hello there, Year 11 mathematicians. Mr. Herman here, and I hope you guys had an enjoyable holiday break. This will be a lesson for exercise 9E, walks, trails, paths, circuits, and cycles. The learning goals for this one is to look into each definition and example of a walk, trail, path, circuit, and cycle. And the success criteria is to determine if specific graphs have trails, paths, circuits, and or cycles based on the definition. Now, before I get into this, this will be the second last video that you have to watch. There will be one more after this for lesson 5. You don't need to watch any more videos after this because we'll be starting back at school week 2, where we'll go back to face-to-face teaching. So I will actually teach the content to you in the classroom setting. Now, ideally, I would have liked to have taught this in the classroom setting, but considering how far behind we are in comparison to last year's schedule, I do need to fit just 2 videos within week 1. But I do have to do this. So it is quite annoying, and I know my videos can get tiresome and whatnot. This video, no exception. It's the only way that we can fit everything in. So there aren't really any examples within this that I'm going to show to you live. This is purely going to be definition based. So many problems can be modeled by graphs that involve moving around the actual graph itself. Therefore, we need to know how to describe these specific movements. So the graph shown to the right here represents the tracks in a place called Sherbrooke Forest. They lead to a suspension bridge, which is dictated by the letter B over here. And there's the bridge itself is just some scenic thing. So these aren't necessarily bridges. In there's this bridge. It could have been a waterfall, or there was already a waterfall. It could be a rock of some sort, but it's just a scenic thing that's there. There's also a waterfall, an old tree, a fern tree gully, and people can either enter or leave through gate G1 or G2. The edges in the graph represent tracks that connect these places. For example, the edge WB, so WB, this edge represents a track between the waterfall and the bridge. So it's pretty simple. It's just like a simplified version of a map that you can see within a track. But what now we want to do is put definitions to this, because we can walk specific routes of some sort, and we want to give this a definition. So the most easiest and common ones we have here is walks, trails, and paths. So a walk is a sequence of edges linking successive vertices or dots that connect 2 different vertices in the graph. So an example of a generic walk is from gate 1 to the bridge, then we go to the fern, back to gate 2, to the tree, to gate 2 again, and to the fern. And you can see this shown in the diagram by these red arrows. So we go up down here. Now it's a generic walk. You can see that certain edges or tracks have been walked over and then walked back. So between the fern gully and gate 2 and gate 2 to the old tree, and obviously you can see that certain places have been revisited again. Now, because of these revisits, this is just considered a walk. So the double red arrows on the graph indicate that this track is walked along in both directions, and a walk does not require all of the edges or vertices to be different. So we don't really cover any of the waterfall or any of these edges here. It doesn't matter. It's just a walk. It's just a very generic walk. So you say, I'm going for a walk, you kind of wander around. But then we get into specific ones where a trail is a walk with no repeated edges. So this forest trail, we're going to start at gate 1. We're going to go to the bridge, to the fern gully, to gate 2, to the tree, to the waterfall, and then to the bridge again, and then to gate 2. Now there's no repeated edges. These edges here between gate 1 and fern gully haven't been walked over. It doesn't matter as long as there's no repeated edges, like in the walk where we go over it again. As long as there's no repeated edges, this is considered a trail. So a trail just means we don't turn back to another part that we'll walk over. Again, it doesn't necessarily matter which places you go to, or if every single edge has been walked over or path has been walked over, as long as it's not repeated. So the red arrows in the graph trace out this trail. It has no repeated edges. However, there is one repeated vertex, G2. This is allowed on a trail. So we go from G2 once, and then we go to G2 again at the end. So there's a bit of a cycle here. That's fine. It doesn't matter if it's repeated, as long as the edges are not repeated. A path is a walk with no repeated vertices. So this is the main difference between a trail and a path. No repeated edges for trails, but no repeated vertices or points of interest for a path. So in this case here, we're at gate 1. We're going to go to the Fern Gully, to the bridge, to the waterfall, to the old tree, and then exit at the gate. And here we can see there are no repeated edges, but on top of this there are no repeated vertices as well. So I like to think of a path as a subcategory of a trail, because with a trail there are no repeated edges. With a path there's no repeated edges and no repeated vertices. We don't head back to a place of interest again. We just see it once and then we're done. So we're following a specific path, and I like to think of a path as just one way of going from a place to another place. And you can go via other places as well, but it's just a continuous path that keeps going along. So these three are the most simple ones, as long as you can read these little green informations that go apart, that's a part of this characteristic of, I don't know what to call them, a way from end to end, then you should be fine. But then it gets a bit trickier when we get to circuits and cycles, because there's very key characteristics that are important within this. So there is nothing to stop a walk, trail, or path beginning and ending at the same vertex. When this happens, we say that the walk, trail, or path is considered closed. Because closed trails and closed paths are so important in practice, we give them special names, which are called circuits and cycles. So in general terms, when you think of a circuit or a cycle, you think of the word circle, and you can see the it starts with C, and you get the CIRC in there. But there are two specific definitions when it comes to graph theory. A circuit is a walk that has no repeated edges and starts and ends at the same vertex. So a circuit, and you can see here circuit, well, circuit cycle, circuit circle, start and end at the same spot. And you've heard the word circuit before. A lot of bicycle riders do a circuit because they want to start and end in the same place, because maybe they've parked their car in the parking lot, which is in the same area. So a circuit, we're going to start at G1. We're going to go to the Fern, to the bridge, to the waterfall, to the old tree, to gate 2, and then cut across, see the bridge again, and then go to gate 1. So it doesn't matter if the bridge is repeated. The circuit begins and ends at the same vertex G1. The red arrow on the graph traces out the circuit, as you can see here, and there are no repeated edges. However, the circuit passes through the bridge twice, and that doesn't matter as long as we don't have a repeated edge. But a cycle is a walk that has no repeated vertices and starts at end at the same vertex. So it's like a subcategory of the path, or special category of the path. So in this specific one here, we start at G2, we go to the bridge, to the waterfall, the old tree, and then back to gate 2 again. So we start and end at the same spot. We don't necessarily see the same vertice or repeat the edge. Now there's more than one way of getting a cycle. We could have just gone like this, we could have gone right around like that, we could have gone through here. As long as there's no repeated vertice or repeated edge, that is fine. And because a cycle has no repeated vertices, there can not really be any repeated edges as well. So you can't walk back, because as soon as you walk back, you're going back to the same vertice, but we can't go to another vertice in the first place, so we won't have repeated edges. So this little diagram here, the summary table, will show you what type of route it is, and you will get questions within your set that's going to ask, what is this specific type of route? whether it's going to be a walk, a trail, a path, a closed walk, a circuit, or a cycle, which is a closed path. And it's going to ask these two questions: are repeated edges permitted, and are repeated vertices permitted? And depending on how you answer those questions will determine what type of route it is. And that concludes this video for this lesson 4. Have a look at your log sheet, see which questions you need to do. There is also a worksheet that is attached to this as well. And until then, I'll see you in the next and final video for this topic. Till then, catch you later.